Welcome back, guys. So in the last lecture I talked to you about the graphs of sin x, graphs of sin x, cos x and tan x, and why sin x, cos x and tan x graphs are important. So in this lecture and the lectures from now onwards, I will be talking about more complex topics on trigonometry, which are the transformations you will see, and how a basic graph, a basic sine graph or basic cos graph or basic tan graph, other than the basic y equals sin x format or y equals cos x format or y is equal tan x formats can be drawn. So first of all, to understand those, you need to understand two terms, and those two terms are the amplitude and the period of a graph. So you may know by now what's known as the period. So you may know by now what's known as the wavelength. Sometimes you will know, if you have studied something in physics or something in chemistry or something, that wavelength is the length between two adjacent particles of the same phase. So that's the simplest definition one can give about wavelength. So period is actually the time taken to cover one wavelength. So that's very easy. Sometimes we call it to cover one cycle, because it's actually cycle. Means if you take this y equals sin x graph here, at 0 it's 0, at 1 and so at 5 by 2 that's 90, it's equal to 1, at 5 it's equal to 0, at 3 5 by 2 it's equal to -1, at 2 and at 2 5 it's equal to 0 again. So it should be of the same phase, means it should be of the same distance from the mean base. So mean base is here is the x-axis. From x-axis on we are measuring the amplitude, and the wavelength is this distance between 0 and 2,5. So that's wavelength, and this is one cycle. So the time taken to cover that area, to cover this wavelength, is called the period. So this is not the period, this is an angle at 0 to 2,5. So this is the distance between, this is equal to some wavelength. The distance is actually the distance traveled by this object, not the displacement. Displacement is 0. The distance traveled by this object from here to here is called the wavelength, and the time taken, if you take the distance of a time graph, the time taken to cover, now this is angle versus the sine graph. The x-axis is the angle and y-axis equal the sine graph. You will see it's also called the sinusoidal graph, and in this graph the x-axis is an angle and the y-axis is the sine variable. As x varies, sine x varies, so y varies. So if you take a distance over time graph, a dt graph, what happens is that if you cover this distance in time t, that t is called the period of that graph, and the distance covered within time t is called the wavelength. So you know now what is known by period, and sometimes you may know that more if you have studied physics or chemistry. So I am not going to talk about period here in detail. And the other thing I want to know is the amplitude. Amplitude is this, the maximum displacement from this. So actually, in quantitative terms, the amplitude of the sin x graph is actually +1, because this amplitude, the maximum height which is during this phase is +1, and I call this as the minimum height. Actually, quantitatively, this length is equal to this length, and qualitatively, this length is plus, we take it as plus, and this length as minus. So actually, quantitatively, this length is equal to this length. So what's amplitude? Amplitude is the minimum, the maximum displacement. The maximum displacement of an object, a particle, or an atom which is traveling in this, actually y equals sin x is actually a wave, like a wave. So traveling in this wave, the maximum displacement from its mean position. So this is the mean position, or we call the base position, or zero level, or something like that. So the amplitude is this one. So this is a simple graph, y equals sin x. So what happens if y is not equal to sin x? That's y equals some coefficient times sin x, coefficient that is constant. So for example, y equals 2 times sin x, y equals half times sin x, so y equals minus sin x. So there is some coefficient in problems that you may face, quizzes or problems or some assignments so you face in trigonometry, you don't find graphs normally which is y equals sin x, because y equals sin x is known by everyone and everyone can draw that graph, so that's very easy. You will not face in problems that they ask to draw the graph of y equals sin x. So often you will get something like y equals 2 times sin x, y equals half times sin x, or y equals sin 2x, sin 2x. So y equals 2 times sin x is multiplying the sin x value by 2 and getting the value of y. So y equals sin 2x is multiplying the angle by 2 and taking the sine of that and equaling it to y. So you will get some graph like that. So to understand and to draw those graphs, first of all you need to know what is known by period and the amplitude. Now I told you about the period and the amplitude of a general equation, general graph or a general wave. So if I take some common equation like this, which y equals a sin bx plus 5. Y equals a sin bx plus 5. So this is the normal graph. Any equation, any sine graph can be drawn from this equation by substituting the values of a, b and phi. So a is called the amplitude, b is called actually the angle multiplication, and phi is called the phase difference. So I'll slowly start the things in detail. For now, don't confuse with the phase difference. For the next problems, I will discuss the phase difference in another video. So for now, I'll take phi equals 0. So that it will be easy for you to understand these concepts. Phi equals 0. Right? So y equals a sin bx now, because phi is 0. A sin bx. A and b are constants. You can change a and b. And you can build up, say, y equals 2 times sin 5x. So a is equal to 2 and b is equal to 5. So what happens is that when x changes, y changes, because x is the independent variable and y is the dependent variable. So y equals a times sin bx. So the amplitude of this graph is called the maximum displacement. So as I mentioned, the amplitude is how much it is increased. So simply the amplitude is there. But amplitude, as I mentioned before, in this graph, in the y equals sin x graph, this length, the distance between the mean position and the maximum displacement, this is plus 1 and this is minus 1. So it will be the same displacement quantitatively. So we will take the absolute value, because we don't need whether it's plus or minus, we need just the amplitude. That means the maximum displacement from the base or from the mean axis. So what we know is that amplitude is the maximum displacement. So the amplitude, we take the absolute value of this one. Amplitude equals absolute A. Right? Amplitude equals absolute A. Okay, and the period is said to be equal to 2 phi by b. Period is said to be equal to 2 phi by b. So this is the graph. So this is a graph for any function. Y equals 2 times sin x. Y equals 2 times sin 2x. Y equals minus sin 2x. So you can you can calculate the amplitude and you can calculate the period, and then you can draw any graph of this format. So it will be the same for any graph of y equals cos b, y equals a times cos bx, or y equals a times tan bx. So that doesn't matter whether you are taking the sine or the cos or the tan or anything, even cosec, cot and sec. So that doesn't mean, the only thing is that if a and b are like this, y equals a times sine bx in that format, the amplitude is the absolute value of a and the period is 2 phi by b. So simply y equals 3 times sine 2x, right? Y equals 3 times sine 2x, the amplitude is equal to absolute 3, which is 3, right? And the period is equal to 2 5 by b is equal to 2. So this 2, so this is 5. So period is 5 means it takes only 180 degrees. So this is actually half of this one. It takes only 180 degrees to cover one cycle. So in the normal vehicle sin x graph, it takes 360 degrees, 0 to 25, 0 to 25. But in this graph, vehicles 3 times sin 2x, it takes only 180 degrees. So actually what happens is that this graph is shrink. This graph becomes like this. And this, the initial point will be the same, but the end point is 125 and the end point will be 5. So I'll discuss that in detail. So that's the introduction to drawing complex graphs. So in the next videos I will be talking about the transformations that you can see by changing and by the values of a and b, and how can we draw different graphs. So that will be very interactive and will be very interesting to you. So I think you have gathered some knowledge from this video. So I hope to see you in the next video, and thanks for watching this video, and see you back.